Okay, so this was the mock paper for Core 1, and because it's the Core 1 paper, obviously you need to get higher in this one than your target grade. So if you're aiming for an A, you need to be hitting the 90% in this paper. If you're aiming for a C, which is usually 60%, you need to be aiming for a good like 70 or 80%. So let's see how to do that. Okay, the first question should be relatively straightforward. You're going to get the first mark for multiplying out the brackets here on the right. So we've got 10 plus x squared is greater than x squared minus 2x. And then we're going to subtract an x squared from both sides, so that gets rid of that one, gets rid of that one. So we're left with 10 is greater than minus 2x. Now, there's two ways of doing this next step. Because you've got a minus 2x here, you can bring that over to the right hand side and have 2x plus 10 is greater than 0. Then take that away. 2x is greater than minus 10. And you can divide by 2 to get x is greater than minus 5. Alternatively, from this step here, you can do another thing, and that's divide by minus 2. And if you divide by minus 2, obviously you're going to get x on the right hand side and you're going to get minus 5 on the left hand side. However, when you divide by or multiply by a negative number with inequalities, this sign changes around. So that's going to be x is going to be greater than minus 5, and minus 5 is going to be less than x, which of course, if you write it the other way around, it's going to look like that there. Okay, so that's that question done. And if we move on to the next one. Now, the main thing to note about this one is that this sign here means that it's an integration question. But we can't integrate at the moment because we've got 1 over x squared and we've got the cube roots of x. So we've got to rewrite that. So we're going to rewrite it as x squared minus 1x to the minus 2. You don't need to write the 1, but you're not going to be penalised if you do. Plus x to the power of a third. That's with respect to x. Okay, so when you integrate, you raise the power by 1 and then divide by the power. So that's going to be x cubed over 3 minus 1x to the power of minus 1 over minus 1 plus x to the power of 4 thirds over 4 thirds. And because it's integration, you've got to put the plus c on the end as well. Now in the exam, a lot of people struggled with the simplification of this last bit here, which we're going to get to. So we're going to have the first one as x cubed over 3. Now dividing by minus 1 just means we're going to change the power, so that's going to be plus x to the power of minus 1, or 1 over x. But this one, if we take this over here, if we've got x to the power of 4 over 3 and we're dividing by 4 over 3, we're dividing by a fraction, so x to the power of 4 over 3 multiplied by 3 over 4. So that's going to be 3 over 4 x to the power of 4 thirds, and of course you've got your plus c as well. So just be careful of that. Obviously you've got to know that this sign here means to integrate, and that means to raise the power by 1 then divide by that power. But get used to doing this though, so you raise the power then divide by that power, so you make sure you've got the first mark, and then you can do this, so you can simplify it. Okay, question 3. Now they're not going to penalise you if you don't put plus and minus here, but the power of a half means the square root, so that's going to be the square root of 81, which is 9. Now if we've got 81 to the power of 3 over 4, whenever we've got a fractional power, the first thing we do is we deal with the bottom. Now the bottom means the root, so that's going to be the 4th root of 81, and whatever that is, then going to cube it. So the 4th root of 81 means something times by something times by something times by something 4 times makes 81. So if we have that as 2, 2 times 2 is 4, times 2 is 8, times 2 is 16. So try with 3. 3 times 3 is 9, times 3 is 27, times 3 is 81. So the 4th root, or the quarter root of 81, is going to be 3. Then we're going to raise that to the power of 3, so 3 times 3 is 9, times 3 is 27. So that equals 27. Then we've got a negative power. And the way we deal with negative powers is we just change it into a positive power. So we're going to write 1 over 81 to the power of 3/4. Now in the last question, we know what 81 to the power of 3/4 is. That's 27. So we're just going to write that as 1 over 27, which is only worth 1 mark, because the only thing you're doing is putting it 1 over the previous answer. Okay, question 4. Now, recurrence relations. Now, a lot of people drop marks on these, so it's worth going through this part of the video a couple of times. So the first thing we've got to do is we've got to write down an expression for A2 in terms of k. So what we do, the whole recurrence relation thing means this is the next term and this is the current term. So if we've got term A1, in order to work out A2, we've got to use A1 to do that. So we can write down that A2 equals 4 lots of whatever A1 is. And you know that A1 is k, so it's going to be 4 lots of k minus 7. And that's it. In terms of A3, so again, using the recurrence thing, the term that you're looking for equals the current term, or the term before the one that you're looking for, take away 7. It's going to be 4 lots of A2. Now we know that A2 is this thing here, so we're going to stick that in brackets. 4 lots of 4k minus 7, take away 7. So all we've done here is we've said that A3 equals 4 lots of A2, take away 7. We've then said that A2 is this thing here, so it's 4 lots of that, then take away 7. Then if we simplify that, 4 lots of 4k is going to be 16k, 4 lots of minus 7 is minus 28, minus 7, so 16k minus 35, and that gets us the 2 marks. You're now told that A3 equals 13, so if this thing here is A3, we're just going to replace that with 13, so 13 equals 16k minus 35, get rid of the minus 35 by adding it, and we've got 16k equals 48, so k simply equals 3. Okay, next one, so simultaneous equations. So the first thing, just for 2 marks, is we've got to show that solving these two simultaneously will lead us to this thing here. So whenever we're going to solve simultaneous equations, what we're going to do is we're going to get either x equals or y equals. So we're going to do that with the top equation, and it makes sense just to get rid of this 2x. So we're going to have y equals 8 minus 2x. So if we get rid of this y here and then replace it with 8 minus 2x, we're going to have 3x squared plus x times 8 minus 2x, and that equals 1. Then we're going to hopefully simplify it, and it should look like this. So 3x squared plus 8x minus 2x squared equals 1. So 3x squared take away 2x squared is going to be 1x squared plus 8x equals 1. X squared plus 8x minus 1 equals 0. Now in theory I could have done 2 of those steps at once, so I could have done 3x squared, take away 2x squared to get the x squared, and then just brought the 1 over. But on this show that question, you've got to put in a few extra steps. Put in as many steps as you can, just to make it really obvious what you're doing. Because you're given the answer here, it's very, very tempting just to go straight to the answer. But what they're looking for is you to know step by step what it is you're doing. Okay, so part B, we've got to solve these simultaneous equations. So it says hence. So when it says hence, that means you've got to use the previous thing that you've been doing to solve this. So in terms of the previous stuff that we've been doing, we started solving simultaneously to get from these 2 equations to this 1 equation. So what we've now got to do is solve this 1 equation. Now when we do that, we usually factorize. There's a couple of things here that sort of tell us that we can't factorize. The fact that this equation is going to be worth 7 marks in total, and simultaneous equations don't usually give us 7 marks, they usually give us 5 or 6. But the other thing is that it tells us that the answer is a plus b root 17. Now whenever we factorize, it gives us nice answers. At worst it gives us a fraction. But here we've got something where we've got a plus b root 17. So therefore it's going to be the messier way of solving a quadratic equation. So what we do is, there's 2 ways of doing it. We can either solve it using the quadratic formula or completing this. Okay, so if we go for the quadratic formula first, and this is something that you need to know because it's not in the formula book, but it's minus b plus or minus the square root of b squared minus 4ac all over 2a. And that's just something that you need to try and memorise. And then a, just be careful with the signs, a equals 1, that's the thing that's in front of the x squared, b equals 8, and c equals minus 1. So then what we do, we're going to substitute it in. So that's going to be minus 8 plus or minus the square root of b squared, so that's going to be 64, minus then 4ac. Now always do 4ac in brackets. So it's going to be 4 times by 1 times by minus 1. And that's all over 2a, so that's going to be 2. So if we simplify that, minus 8 plus or minus the square root of 64 minus 4, so that's why we do it in brackets. So this thing here simplifies to minus 4, so that's 64 take away minus 4. Just be careful with those signs, all divided by 2. Now the mistake that a lot of people made on the exam was they only divided the 8 by 2. But first of all, we're going to simplify this fraction. So we've got minus 8 plus or minus the square root of 68 divided by 2. Now you know that your answer is going to have a root 17 in it. So minus 8 plus or minus the square root of 4 times the square root of 17, that's what 68 is, 4 times 17, all divided by 2. Which we then simplify, minus 8 plus or minus the square root of 4 being 2, so that's going to be 2 root 17 over 2. So our two answers are minus 4 plus square root of 17, because you divided the 2 by 2, minus 4 minus the square root of 17. And again, a lot of people dropped the final 2 marks because once you get those, and those are the correct answers, they're not the final answers. Because when you solve simultaneous equations, you don't ever leave it where you just find the x values. We've got x equaling this and we've got x equaling that. For the whole thing with simultaneous equations, you've got to work out what the y values are. So we know that y equals 8 minus 2x. That's the very first thing we did on part A. So we know that y equals 8, take away 2 lots of x. That's going to be 2 lots of minus 4 plus root 17. So it's going to be y equals 8 plus 8 minus 2 root 17, which equals 16 minus 2 root 17. If we do that with the other one, so that's with that one there, do the same with this one here now. Y equals 8 minus 2 lots of minus 4 minus root 17. So if we simplify that, minus 2 times by minus 4 is going to be minus, so that's going to be plus 8. So that's going to be 16, and then minus 2 times by minus root 17 is going to be plus 2 root 17. So those are the two values of y as well. Okay, so now moving on. To question 6. So the first one, we've got to show that we can rewrite this. So in order to do that, we're going to need to multiply out the brackets using the smiley face method. And doing so will give us f of x equals 2x squared plus 4 plus x plus 8x. Just be careful with this one. 2x times by 4 is going to be plus 8x. And that's all going to be over the square root of x, which we're going to write as x to the power of a half. If we then simplify that, that's going to be 2x squared plus 9x plus 4 over x to the power of a half. Now, the stuff that you've learned in GCSEs, if you've got x to the power of 7 divided by x to the power of 3, that becomes x to the power of 4. You just subtract the powers. So if we're going to split these into 3 separate things here, we're going to have 2x squared over x to the power of a half, plus 9x over x to the power of a half, plus 4 over x to the power of a half. So just like this one here, all we're going to do is we're going to subtract the powers. Okay, so with the subtraction of powers, if you've got 2 take away a half, that's going to be 1 1/2. However, 1 1/2, when we deal with integration and differentiation, we usually use that as 3 over 2. So that's going to, so f of x equals 2x to the 3 over 2. Doing the same with this one here, that's going to be plus 9x to the power of 1/2. And here, there's nothing on the top, so we can just bring this up to the top. Remember, when we do that, we need to change the sign. So that's going to be 4x to the power of minus 1/2. And that's what you need to get the first 3 marks. The next thing you've got to do is we've got to find f dashed of x. Now what this means, this is where we differentiate it. So just like dy by dx, they mean the same thing. So if this was written as y equals, they'll ask you to find dy by dx. If it's written as f of x, then you've got to find f dashed of x. It's just the shorthand way of writing that down. So if we've got our answer here, so f dashed of x, so when we differentiate, the power comes down to the front, so that's going to be 3 over 2 times by 2x, then the power goes down by 1, so that's going to be to the power of 1/2, plus 1/2 times by 9x, then the power goes down by 1. So remember, when you take away a power, and this goes to the first one as well, when you take away 1, if we've got a fraction, have a look at the bottom, and if it's halves, we're going to take away 2 halves. If we had x to the power of 4 over 5, we take away 5/5. So here we're going to take away 2 halves, so that's going to be 9x to the power of minus 1/2. If we take away 2 halves from that, that's going to be plus, and then minus 1/2 times by 4x to the power of minus 3 over 2. So then we've got to simplify it. So if we multiply 3 over 2 by 2, so 3 over 2 times by 2, whenever we multiply a fraction by a whole number, just multiply the top numbers together, so 3 times 2 is 6, then we divide that by 2. So 3 times 2 is 6, divided by 2 is 3. So 3x to the power of 1/2. Plus 9 over 2, or 9 halves, x to the power of minus 1/2, and then minus 1/2 times by 4 is going to be minus 2, x to the power of minus 3 over 2. And that's it, that's what we need from f dashed of x. Now, the next thing we've got to do is we've got to show that the tangent to the curve where the x value is 1 is parallel to the line, this thing here. Now again, this is more an understanding question than anything that's going to be too taxing in terms of the maths. So the reason that we do f dashed of x, that's our gradient function, just like dy by dx is. And all that does is tells us the gradient of a curve at any point. So the reason that we've got to show that it's parallel, all we've got to do is we've got to find the gradient of the curve when x is 1. Then we've got to find out what the gradient of this straight line is. So to find out the gradient of the curve, we substitute in x equals 1 into that. So it's going to be 3, x to the power of 1/2 means the square root of 1, so 3 times the square root of 1, plus 9 over 2 times by x to the power of minus 1/2 means 1 over the square root of 1. Take away 2 times 1 over the square root of 1 cubed. Now the square root of 1 is always going to be 1, and 1 cubed is always going to be 1. So these things here just cancel down to 1 each time. So we're going to have 3 plus 9 over 2, so that's 4.5. Take away 2. And if we do that, that's going to be 5.5. Remember, that's what f dashed of x is, and again it bears repeating. F dashed of x means the gradient, so the gradient is 5.5, and we've got to show that's parallel to the gradient of this line. So we've got to work out what the gradient of this line is, and the way we do that is we rearrange it so it's y equals. So if you divide everything by 2, we've got 11 over 2x plus 3 over 2. So the gradient is this here, 11 over 2 equals 5.5. So I'd say that is the gradient of the line. I'd say this is the gradient of the curve at x equals 1. And then I'd say same gradient, because you've got to show, so same gradient, therefore parallel. And if you haven't seen that before, those three dots means therefore. Okay, moving on to the next question. So now on to question 7 of 10. Now, factorise completely. Said this loads and loads of times, so you should be quite comfortable with this question because it comes up a lot. So if you've got to factorise something with an x cubed in core 1, then all you've got to do first of all is take out the x. That's going to be x squared minus 4. And then this you've got to be able to spot as a difference of two squares. Because you've got to factorise this, but there's nothing that goes into x and there's nothing that goes into 4. So what you've got to do is you've got to notice that this is x times x, this is 4 times 4. So when we factorise that, it's going to be x plus 2 and x minus 2. And then we've got to sketch that. So if we sketch that, the place where it goes through the x-axis is when this equals 0, this equals 0, and this equals 0. So that's going to be 0, minus 2, and 2. And because it's an x cubed, what we know is that that's a positive x cubed, so therefore it's going to be a graph which looks like that. That's all we do. If you draw it with a nice smoother curve than mine's got there. So doing that gets you 3 marks. That's 6 marks on this question, really, really quite quickly. Now the next bit is where a lot of people fell down. And what you've got to do is you've got to spot that this here, y equals x minus 1 cubed minus 4x minus 1. And this is y equals, at the top here, y equals x cubed minus 4x. So all they've done is they've replaced the x with x minus 1. So you've got y equals x cubed minus 4 lots of x, and y equals x minus 1 cubed minus 4 lots of x minus 1. So if you've got a graph which looks like f of x, and then you've got to do f of x minus 1, you should know that all you've got to do here is just pick the graph up and move it to the right by 1. Because when you've got the x minus 1 in brackets, you just move it to the right by 1. So all we're going to do here, and we have to do this on separate axes, but I'm going to draw on this one to make it look clearer. All you're going to do is going to move this point over here, so that's going to be minus 1. This point is going to go over here, which is 1. This point is going to go 1 to the right, make that 3. Then we do the same thing. That's it. That's our 3 marks. And all we've got to do is show in the coordinates where the points, where the curve crosses the x-axis. That's at minus 1, 1, and 3. If you want to, you could find out where it goes through the y-axis as well. In fact, the y-axis would be the top of that there. And to find out where something goes through the y-axis, you set x equal to 0. So that's going to be 0 minus 1 cubed and 0 minus 1. So minus 1 cubed is going to be minus 1. Minus 4 times by minus 1 is going to be plus 4. So minus 1 plus 4 is going to be 3. You don't need to do that to get the marks on this one, but that's how you would get the marks. Okay, 3 more questions. So the first part of this is quite nice. So you're told that L2 is perpendicular to L1. In fact, let's do a little diagram just so that we can see what's going on here. So we've got y equals 3x minus 6. So it goes to minus 6. It's going to go up like that. To find out where this, well, it shouldn't be a curve, it should be a straight line. To find out where it goes through the x-axis, you've got to set y equal to 0. So 0 equals 3x minus 6. 3x equals 6. X equals 2. So it's going to go through at 2. You don't need to do that for this question. And we know that the straight line L2 is perpendicular to L1 and passes through the point 6, 2. Find an equation for L2. So as soon as it says find an equation, the first thing we're going to do is write down y minus y1 equals mx minus x1. Now we need 2 pieces of information. We need to know a coordinate that it goes through. It tells us that's 6, 2. That's going to be y minus 2 equals x minus 6. But we need to know the gradient as well. And what we're told is that the gradient of L2 is perpendicular to L1. So what we need to do is we need to work out what the gradient of L1 is, then find the perpendicular gradient. So if we have a look here, we've got y equals 3x. So the gradient for this line is 3. So if the gradient is 3 for the first line, the perpendicular gradient, you flip it upside down and you change the sign. So that's going to go to minus 1 over 3. So we get that. So y minus 2 equals minus 1/3 x minus 6. And then we've got to have it in this format here. So we've got to multiply out the brackets. So y minus 2 equals minus 1/3 x. And minus 1/3 times minus 6 is going to be plus 2. Then I'm going to add 2 onto it. So we've got y equals minus 1/3 x plus 4 for 3 marks. The lines L1 and L2 intersect at point C. So if we quickly sketch this one goes through at, so it's y equals minus 1/3 x plus 4. So this plus 4 is where it goes through the y-axis. So if we do this in a slightly different colour, so it's going to go through at 4, and the gradient's going to be minus 1/3, so it's sloping downwards, but just not that much. So what we want to do is we want to find out this coordinate here, and that is point C. So to find out where two lines intersect, we need to solve them simultaneously. And we've got the two equations of a line. We've got y equals 3x minus 6, and we've got y equals minus 1/3 x plus 4. Now because they're both y equals, to solve them we just set them equal to each other. So 3x minus 6 equals minus 1/3 x plus 4. Now the thing that makes this slightly harder, or the thing that makes it tricky at all, is the fact that we've got a minus 1/3 there. So we're going to get rid of the fraction by times him by that 3. So, but it's an easy mistake to make this. Make sure we times everything by the 3. So that's going to be 9x. That's going to be minus 18. This just goes to minus 1x. But we've also got to multiply this by minus 3, or multiply this by 3, sorry, to get 12. And that's something that a lot of people don't do. People don't multiply this thing here by 3. So then we've got to get all the x on the left-hand side, because there's more of them, so we're going to get rid of the minus x by adding it over. We're going to get rid of the minus 18 by adding it to the right-hand side. And we end up with 10x equals 30, so x equals 3. So the x-coordinate there is 3. And to find out the y-coordinate, we're going to substitute it into one of the easier ones, so let's substitute it into that one. So y equals 3 lots of 3 minus 6, which equals 3. So x equals 3, y equals 3. And that's it. The next thing it says, the lines L1, L2 cross the x-axis at points A and B respectively. Now, we know that L1, so if we just say on here, that's L1, and this is L2. We know that this one crosses at 2. So if we do another sketch here, we've got that line, we've got this line here. We know that goes through at 2. We know that they meet at point 33. So that's A, that's B, and that's C. So we've got to find out where that point is there, and then we've got to work out what the area of this triangle is. Now the area of the triangle isn't going to be too bad, because it's just base times by height divided by 2. So if the equation of this line, or this line here, is y equals minus 1/3 x plus 4, to find out where that goes through the x-axis, that's going to go through when y equals 0. So 0 equals minus 1/3 x plus 4. Bring the third x over to the left-hand side, so that's going to be 1/3 x equals 4, times by 3, and we've got x equals 12. So we know that this line here goes through the x-axis at 12. So we've got to do base times height divided by 2. Now the base is from 2 up to 12, so that's a gap of 10, times by the height. Now, by definition, the fact that the coordinates is 3, 3 means that's 3 across 3 up. So therefore the vertical distance is 3. So 10 times 3, then divided by 2, that's going to be 15. And in theory you should write 15 units squared, but I've never seen them docu marks for not putting in units squared. Okay, question 9. Now the first part of this question is just something that you're going to need to learn, just remember. And that's the proof for the sum of the series. We've got to prove that it's this thing here. So it was half n, or n over 2, 2a plus n minus 1 d. So the way we do that is we write down the sum of the series is the first term plus the second term, which is a plus d, plus a plus 2d plus a plus n minus 2d is the penultimate one, plus a plus n minus 1d. And that's the last term. That's the nth term. Then we're going to write that out again, just back to front. So a plus n minus 1d plus a plus n minus 2d plus plus a plus d plus a. And then what we're going to do is we're going to add the first term to the first term here. And that's going to be a plus a is going to be 2a, plus we got this n minus 1d. So that's if we do Sn plus Sn, that's going to be 2 lots of the sum of the series. Then the next one, we're going to do a plus d plus a plus n minus 2d. Now, obviously that's still going to be 2a, but it's a little bit hard to get your head around what d plus n minus 2d's are. So just imagine n equaling 100. So that's going to be d plus 98d. So d plus 98d is going to be 99d. So that's still going to be, so 99 is going to equal n minus 1. So that still equals n minus 1 d's. And then you keep on going on. A plus n minus 1 d plus, 2a plus n minus 1d plus 2a plus n minus 1d. And what you've got is you've got all of them at 2a plus n minus 1d. So another way of writing that would be n lots of it. So we've got 2 lots of Sn, and that equals n lots of 2a plus n minus 1 d. But this is the sum for 2 lots of the sum of the series. So to find out what the sum of the series is, we simply divide by 2. So n over 2, 2a plus n minus 1 d. So that's how to work it out. However, you don't need to understand that, you just got to memorize how to do it. So the first thing you do is to work out the sum of a series. You write down Sn, and you write down the first term plus the second term plus the third term, all the way up to the last term here. So a plus d plus a plus 2d. You then write out again, just back to front. And then you've got to remember that this bit here is what all of them add up to. So there's going to be 2 lots of the sum of the series equals loads of that. You then factorise that by saying n lots of it. You then divide by 2. Okay, so we've then got an actual question based on this. So we've got a polygon which has got 16 sides. The length of the sides of the polygon, starting with the shortest side, from an arithmetic sequence with common difference d. So we've got a, we've got a plus d, we've got a plus 2d, all the way up to a plus 15d. Because that's going to be a plus n minus 1d. And if we've got a 16-sided shape, n minus 1 is going to be 15. So we're told the longest side has length 6 centimeters. So that last one there, we know that a plus 15d equals 6. And we know the perimeter is 72. So that's all of them added together makes 72. So we know that the sum of the series, 72, equals n over 2, but n over, so in fact if we write that out differently, Sn equals n over 2, 2a plus n minus 1d. Now sometimes it's useful to write this out as, instead of 2a, write out as a plus a, and it will be in this case. So let's fill in the information that we know. So we know the sum of the series is 72. We know that n is 16, so that's going to be 8. We don't know what a is, because that's what we're trying to find. We're trying to find the shortest side. So we don't know what a is. But we do know that a plus n minus 1d, that's going to be the last side. So that's going to be a plus n minus 1d, or a plus 15d, equals 6. So it's a plus n minus 1d, or a plus 15d, a plus 15d equals 6. So we're just going to get rid of that and replace it with a 6. Okay, so then if we divide by 8, that's going to be 9 equals a plus 6. So a simply equals 3. And then we've got to find out what the value of d is. So we're going to substitute in a as 3 here. So it's going to be 3 plus 15d equals 6. 15d equals 3. d equals 3 over 15. Then we cancel that fraction down, divide top and bottom by 3, and we get 1/5. Okay, and then the final question. And again, a lot of people got a lot of marks on this, so I was happy with this. So we've got dy by dx, and then we've got to find d2y by dx squared. So that just means we differentiate it again. So x cubed goes to 3x squared. 2x just goes to plus 2. And remember that 7, because it's not got any x on, just disappears. Now this one is where people did fall down. So show that d2y by dx squared is going to be greater than or equal to 2 for all values of x. So we have a look at this. We've got d2y by dx squared equals 3x squared plus 2. And it's only worth 1 mark. So what I would do is I would say x squared will always be positive, as when you square a negative number, it becomes positive. So repeating itself there. So the smallest this could ever be is when x is 0. X equals 0. So 0 squared equals 0. 3 lots of 0 equals 0. So we're still left with plus 2. So you don't actually need this bit here. So you just need to say that x squared will always be positive. So therefore, smallest it can be is 2. Now we're told that 0.24 lies on the curve. Now we've got curve here which is y equals fx, but we haven't got the equation of the curve. What we've got here, and this is what your most recent homework was, we've got the gradient function. Now to get from the gradient function to y equals, we've got to integrate. And this is what you've got to be able to identify. You've got to identify this question here. It says find y in terms of x. When it says find y in terms of x, it means you've got to find the equation of the curve. But all we've been given is we've been given the gradient function. So what we're going to do is we're going to integrate it. So x cubed goes to x4 over 4 plus 2x squared over 2. Integrate this and that becomes minus 7x. Then we need a plus c. So in order to find y in terms of x, we've got to integrate our gradient function. And until you've done 5, 6, 7 of these questions, it won't always become obvious. So then what you've got to do, we can't have the plus c in it, and that's why they've given us a coordinate. So what we do is we substitute in our value of x as 2 and y as 4. So 4 equals 2 to the power of 4 divided by 4. These 2's will cancel, so that's going to be plus 2 squared minus 7 lots of 2 plus c. So 4 equals 2 to the power of 4 is 2, 4, 8, 16 over 4, which is 4. 2 squared is going to be 4 minus 14 plus c. So 4 equals, that's going to be 8 minus 14, which is going to be minus 6 plus c. So c equals 10. So once you've figured out that c is 10, you've got to rewrite your equation here. But instead of c, we're going to write it as plus 10. So we've got y equals x to the power of 4 over 4, or a quarter x to the power of 4, plus x squared minus 7x plus 10. And that's worth 5 marks. Next thing we've got to do is part D. So we've got to find an equation for the normal at C. So we know that the gradient well, we've got to work out what the gradient is at C. We've then got to work out what the normal gradient is. So, it says find an equation for the normal. So as soon as it says find an equation of a line, y minus y1 equals mx minus x1. We need to have a coordinate. So the coordinate p is 2, 4. So that's going to be y minus 4 equals x minus 2. And then we've got to work out what the gradient of the normal is. Now remember, the normal is the perpendicular gradient. So if we substitute in 2 into this, we're going to work out what the gradient is. So that's going to be 2 cubed plus 2 lots of 2 minus 7. So that's going to be 8 plus 4 minus 7. So that's 12 minus 7, that equals 5. So therefore, if the gradient of the curve is 5, the normal to the curve is going to be, flip that upside down and change the sign. So it's going to be minus 1/5. And they want it in the form ax plus by plus c equals 0. So we're going to multiply through by 5. So that's going to be 5y minus 20 equals and then we multiply the brackets. Minus 1 times x is going to be minus x. Minus 1 times 2 is going to be plus 2. Now I prefer it when x is positive, so I'm going to bring everything over to the left hand side. So it's going to be x plus 5y minus 22 equals 0. And that is how you do all the questions on your mock exam. What I would suggest strongly, because this was the mock paper by Edexcel, read through it, make sure you go through and do this as many times as possible until you're completely confident on all of these questions. If you're confident on all these questions, the exams never change that much. So if you're confident on doing this, chances are you're going to be very, very confident when you sit your exam. Okay, thank you very much.